day everyone, we are now going to discuss about correlation. At the end of the lesson, you are expected to calculate the Pearson sample correlation coefficient and solve problems involving correlation analysis. What I know. Direction. The table below shows the correlations of the four graphs. Match each graph to the correlation coefficient. So correlation negative 0.72, 1, negative 1, and 0. Now here are the answers. On the correlation negative 0.72, so the graph is D. On number 1 correlation, that is on the graph A. On negative 1 correlation, that is on the graph B. The 0 correlation is on the graph C. Correlation analysis. It attempts to measure the strength of the relationship between two variables by means of a single number called a correlation coefficient. Pearson correlation coefficient. It measures the strength of the linear relationship between two variables x and y. The estimated sample correlation coefficient denoted by R is given by R is equal to n times the summation of xy minus the product of the summation of x and the summation of y over the square root of n times the summation of x squared minus the square of the summation of x multiplied by n minus the summation of y squared minus the square of the summation of y, where n is equal to the number of pairs of scores, and summation of xy, that is the sum of the products of paired scores, the summation of x, that is the sum of x scores, and summation of y, that is the sum of y scores, summation of x squared, that is the sum of squared x scores, and summation of y squared, that is the sum of squared y scores. So Pearson R and its qualitative description. Positive or negative 1, that means it is perfect. Positive negative 0.75 to less than positive negative 1, that means it is very high. Positive negative 0.50 to less than positive negative 0.75, that means it is moderately high. Positive negative 0.25 to less than positive negative 0.50, that means it is moderately low. Greater than positive negative 0 to less than positive negative 0.25, that means it is very low. And 0 means no correlation. Remarks. Pearson correlation coefficient R will range from negative 1 to positive 1. That is, negative 1 is less than equal to R is less than equal to 1. When R is close to positive 1, this indicates a positively high linear relationship between the two variables x and y. That is, if the value of y increases when the value of x also increases. When R is close to negative 1, this indicates a negatively high linear relationship. When R is near to 0, this means that there is a lack of linearity between the two variables, or there is no linear relationship between them. Note that this doesn't mean they are not associated at all. Now here is the graph of positive correlation, no correlation, and negative correlation. Now let's have an example. Find the value of the correlation coefficient from the following table. So the first column is the subject, the second column is the age, and the third column is the glucose level. So subject 1 has the age of 43 and a glucose level of 99. Subject 2 has the age of 21 and a glucose level of 65. Subject 3 has the age of 25 and a glucose level of 79. Subject 4 has the age of 42 and a glucose level of 75. Subject 5 has the age of 57 and a glucose level of 87. Subject 6 has the age of 59 and a glucose level of 81. Now here is the computation. For subject 1, so XY, so we will multiply the age and the glucose level. That is 4,257. For the X squared, or we will square the age, that is 43 times 43. That would be 1,849. For Y squared, so we will square 99. So 99 squared is equal to 9,801. For subject number 2, the XY, so 21 times 65, that is 1,365. For X squared, so we will square 21, so that is 441. Next, we will square 65, so that is 4,225. Next, for subject number 3, for XY, we will multiply the age and the glucose, so that is 1,975. Next, we will square the age, so 25 times 25, that is 625. Next, Y squared, so we will square the Y, so that is 79 times 79, that is 6,241. Next, subject number 4, so we will multiply 42 and 75, that is 3,150. Next, we will square the X, 42 times 42, that is 1,764. Next, we will square the Y, so 75 times 75, that is 5,625. Next, subject number 5, we will multiply 57 times 87, that is 4,959. Next, we will square 57, that is 3,229. Then we will square the 87, that is 7,569. Next, for subject number 6, we will multiply 59 times 81, so that is 4,779. Next, we will square X, or 59 times 59, that is 3,481. Then we will square the Y, which is 81 times 81, so that is 6,561. After that, we will have to get the sum of the age. The summation of X, that is 247. Then the summation of Y, that is 486. The summation of XY, that is 20,485. Summation of X squared, that is 11,409. Then summation of Y squared, that is 40,022. So let's now compute for the R. R is equal to N times the summation of XY minus the product of the summation of X times the summation of Y over the square root of N times the summation of X squared minus the square of the summation of X multiplied by N times the summation of Y squared minus the square of the summation of Y. So R is equal to 6 times 20,485 485 minus 247 times 486 over the square root of 6 times 11,409 minus the square of 247 multiplied by 6 times 40,022 minus the square of 486. So R is equal to 122,910 minus 120,042 over the square root of 68,454 minus 61,009 times 240,132 minus 236,196. So R is equal to 2,868 over the square root of 7,445 times 3,936. So R is equal to 2,868 over the square root of 29,303,520. So R is equal to 2,868 over 5,413.27. So R is equal to 0.53. So the correlation is 0.53. It means that it is moderately high correlation. That means that when the age is increasing, the glucose levels is also increasing. Now here are the references. Thank you very much for watching and listening. Please subscribe to Analyze Math for more content.